Hey, my name is Kirill, and I'm going to talk a little about the infrastructural side of cyber network. As known, cyber network is a state-proof network where consensus is achieved by the validators with some staked tokens, actually. Let's say you know like heard somewhere about the cyber, and you decided, like, you searched something, you decided that it's cool, and you wanted to launch your validator. So what do you need to do? Like basic few steps. The most update and the most new things are coming on our GitHub in our Cyber Congress CyberD repo. In a section of docs, you can find the Run Validator guide. But if you want a little bit more and simple way to access it, you should better go to Cyber Congress AE. Right on the left side, you will find the Run Validator doc link. First of all, few words about the requirements to your node, to your server. What do you need to have to be comfortable validating our network? So there is a few recommended parameters. We advising to keep them to be good, to validate good. 6-core GPU, 32 gigs of RAM, at least 256 gigs of SSD, and some Nvidia GeForce or other family Tesla Titan, Quadro, whatever you have, CUDA cores card with at least 6 gigs of memory. And we recommend to run it all on Ubuntu 18.04. Is currently the most tested and working for sure, so that is required. But of course, you can set up a little bit less cool machine. It will work also. The most important thing basically is just a graphic card with the CUDA cores on it. So at least something like few CUDA cores, and you would be able to count the rank and validate. But the more the better, of course. So I'm going to demonstrate a demo, live setup the node, the validator node. We'll follow step by step to this guide. I have here on the left side of the screen a machine sitting here in the office. It's Mars, our helper and friend. So it's just clear. There is nothing besides the Ubuntu running on it currently. I'll just go ahead and copy and paste all these commands from the guide. Maybe would be not that interesting, but it should be good as a demo. So anybody would be able to make sure that it's working and just view this video later on the YouTube. All right, so installing the Docker keys, GPG keys, okay.
So right now you're basically setting up a node, right?
Yeah,
right, yeah.
Setting up a node. Here's the Docker, the most recent Docker. I believe it's 90.03 is required as least, because it would not launch on an older version. Okay, we recommend to use a partainer, but that is optional thing to manage your containers, to view generally what is going on the node. So I'm probably gonna skip it for now. Well, it's just up to you. It's pretty much straightforward. Nothing really complex. All right, interesting part, and one of the most important ones, Nvidia drivers. as far as we have the graphics card installed to this node, we're supposed to have the right drivers to allow the chain work like correctly and good with the card. So going to add some Nvidia's repos to the system really fast. Okay. All right, so driver version currently required, like the least driver version is currently required for the chain is Nvidia 410, but of course the newer the better. So let's see which devices do we have here, which cards. All right, yep, cool. We have something from Nvidia, and there is a 440 current, the most recent version of driver. So just going ahead and install the most current one. Doing the auto install, it just installs the most recent version for us. Yeah, this, oh, looks like I already have it installed here. All right, so that's better for us because normally it takes like maybe up to 10 minutes to install that, so it's good for us. And normally after the first installation, it is required to reboot the server, but let's see, as far as I have it installed already, I probably would not have to do that. Yep, it's working. So the driver version we have is 440.36, CUDA version 10.2, and the card we have is GTX 1660 with a 6 gig of memory, which is good enough. As far as we can predict, it should fit up to 200 million links, like graph with 200 million links into it, which is, I guess, kind of a cool. All right, next important thing, Nvidia container runtime, which has been updated in a while, so that is important thing. And for everybody who's watching this video and updating his old node, like in case if somebody's validated us in EULAR 4, so that is very important thing because that has to be upgraded and nothing gonna work with it. Like the drivers is so far so good with the old ones, but Nvidia container is very important. Okay, we good. We see our output is like pretty much same as shown in a guide. So I'm just going to get and install Nvidia Docker 2 daemon and restart the Docker real quick. Okay, and then we're gonna go ahead and check out our installation. If everything is correct, we should see this table. Yeah, so basically it just pulls these CUDA 10.0 daemon, Docker daemon, and tested that like your installation is good, your drivers is good, and as well, table here is not very similar to what I have, but in reality it is. Okay, so now it's time to launch the CyberD full node. I'm gonna go ahead and create a folder where we're gonna host all the stuff. Okay, all right. So now we're gonna go ahead and pull our container. So that is important stuff. First of all, a few things here. Start from the end of this command. Important ALR, like basically the container version, which is good for ALR 5 network, is held under cyberd/cyberd ELR5 on a Docker hub. So pay attention to this. Next, we're going to go ahead and put the correct folders. So I just created in the root ELR5 folder with cyberd CLI, and then same for the cyberd. Okay, we allowing search on this node, but well, as far as it's set as we're setting up the validator, is a good thing maybe to disable that. I'll touch it a little bit later in security sides of a problem, but let's just disable it. False. Okay. All right. Another important thing: ports. To allow your node to communicate with the world, with the entire network, it's very important to make sure that you will set up the proxy ports on your local router to direct machine, to direct IP of the machine, entire the network. So I have the ports from 37,000 to 38,000 forwarded to my node. So I'll just do these 37,000 something. Here I'm gonna replace 26 to 37 also. Same here. Okay, so the most important is port 26656, which is the main communicational port. For the node 57 port is for API, and 1317 is for LCD REST server. We're going to name our container ELR5, and let's see, it should be it. Let's try to pull it.
Can we make the console maybe a little bit bigger?
Yeah, let's try to. Does someone remember the shortcut?
Does anyone remember the shortcut?
For the console. All right. Command plus. Yep.
Yay, thank you.
Like this, or?
Yep. Yeah, I think it's
good enough. Okay, cool. You should have noticed that earlier. But anyway. Okay, so it's pulling the container currently. Yeah, internet is not very fast at the moment in our office because there's too many people using it, but let's wait a second until it's done. So while that pulling, a little bit later in this speech, I'm going to cover the security sides of the node, of how to set up the some security aspects, like connecting to the node, firewall, stability sides of the node, key management, and we'll talk a little bit about the Sentinel infrastructure, which is kind of a required for the validator to be set. All right, it's almost downloaded. Yeah, looks like we're not meeting up our requirement. We require 100 megabit per second fiber connection, and we don't have it at the office. So keep up to requirements and you'll be cool. Cooler than cool, yeah. All right, looks like it's launched. All right, let's see what's going on there. All right, it's applying Genesis. Looks like it pulled up everything correctly and started up. And if I'm correct, it should start syncing in a minute after Genesis would be applied. How many blocks do we have in a nowhere currently? Well, it's 12K blocks. So yeah, probably whenever it will start to sync, we'll just leave it and switch to the next points. Yeah, because 12K is not a lot to think, but yeah, a couple minutes will be. So.
I have a question for you while we're waiting.
Yeah.
About the monikers, is there a problem if the monikers repeat themselves? Like, let's say we have like the fuck Google will probably be a very popular name, I presume. Is that a problem?
Yeah, it is actually like technically possible to choose whatever moniker you have, and there's no restrictions of like reusing the moniker. So you create like 10 more validators with a fuck Google moniker, but the good idea is to fill up your validator. Oh yeah, blocks to start ticking. Cool. To fill up your validator with the details, like link to your website, any kind of a logo or like a pic, you can attach, so people would know like under the hood who is who and who is the most true fuck Google validator. Valerie's currently is. So yes, stake to him.
Yeah, he stole my monikers, from ULF4. First come, first served. Nah, I'm kidding. No,
Yeah,
so it's basically just a front end thing, right? It's not.
Yeah, kind of a yeah. It is stored in a chain actually, but it could be like the moniker itself could be changed anytime you want, and like to anything you want basically. Go ahead.
I mean, just give it the mic, because.
Can you give us a short overview of the files in a CyberD repository? I mean, the node key, JSON, the prior key, yeah, all of them, please.
Okay, so think is started. Let's leave it for a second to spin in the background.
Make the console full screen.
Oh, sure, no problem. Yep. All right, so about the files. Misspelling. All right, let's see what we have inside of a ELR5 folder that we created. So, like, we'll do step by step. So here's the two folders with the CyberD and the CyberD CLI. So let's take a look what's inside a CyberD. All right, and here's the two folders, config and data. So data is where all the block store is stored, correct? And the config is the most interesting, I guess, folder for you. So let's switch into it and take a look what's going on here. All right, address book, well, straightforward. Yeah, node put all the addresses of the nodes which it could like discover to it. App.toml, not so interesting actually. All right, config. Config toml is your like config file where like all the information stored about the peers, about the external IPs, about the settings of the node. So we'll probably have a closer look to it a little bit later during the security session. Genesis JSON is our Genesis file. See, it's 321 megabytes because it contained like over 1 million addresses inside of it. Node key JSON is your node key, like unique key generated during the node start. It's like attached to, depends on your hardware, like of the MAC addresses or like something like that under the hood. So it's basically unique for every machine. And the pre-validator key is your like same constructed from the like machine ID and unique for your validator. Okay, so notice thinking in the background. Let's talk a little about the security. Now it's a good time, I guess. So the good things we advise to set up to harden the security of your node is like set up the secure way to sign in. For example, if it's the cloud node, which is possible generally to keep it in a cloud. It's very important to secure your SSH connections as far as like possible. So big idea to allow only login through the public key from your like local machine. Add your local machine public key to your node. Possible to set up the two-step verification on the machine, to use something like a Google or whatever's app for generating one-time passcodes to access it. And about the few things about the node location. So stability of the work of the validator and availability on the network and uptime is the key features of the like cool validator. So let's see. Where's my Chrome? No, come on. All right, go like this. All right, so we have the validators tab, and here's the uptime showing. So that is the uptime for last couple hundreds of blocks maybe, but it's like basically showing how many blocks your validator since those last couple hundreds was up and how many was down. So when you see 100 there is the cool, it's like very cool, and to achieve the biggest uptime, like 100% uptime, it is recommended to launch your node in a cloud, like somewhere. There is a couple, like technically a couple providers, like a Hertzner and a few from America, as far as I know, who's providing the GPU dedicated service to rent in the cloud. So they are backed up with the internet, with the electricity, and like hurricane proofed and so far. So apocalypse would not probably be your node like first if you will carry it in a cloud. So we generally we recommend to keep the node in a cloud to achieve the best uptime and online time. Okay, another few words about the key management. Let me switch back to my console. So all the keys are stored inside of your node, and like restricting access to it, like including the physical access, it's a very good idea to keep it safe. So in case you running, from your home or from your like somewhere locally, it's a good idea to set it in a place which would not be accessible by somebody else. It's a good idea to use like the strong passwords, not 123 and a password word. That's the basic stuff. Also, oh yeah, one more thing. It is possible to launch our node from the ledger, using the ledger and Tendermint KMS like key management system. So we have also the guide on our Cyber Congress website for it. Yeah, it should be pretty much straightforward, but not very finished as far as I know yet. But yeah, currently you may go ahead and use it and set up your node from the ledger. So you will keep your validator key on the ledger and sign the blocks using the ledger, which is cool, I think. Key management we covered. Okay, let's see what's going on our node.
Kirill, maybe we can go with the config file and you can talk about the seed nodes and the peers.
Yeah, that's what I was going to talk next. Yeah, I'm just going to see how many blocks do we have sync here. 4.5 Ks. Okay, let's leave it spin and talk a little about the config. All right, here's the config file of your node. First of all, you'll see here the moniker. I have the fuck Google. Yeah, which we can change, of course. I'm not going to duplicate. I'll just put a Mars. Some options about the sync. Can skip that a little. So like pointers to files, the node key to Genesis files. All right, here second, like another important point, RPC. If you are going to access the RPC of your node, like somewhere like locally, so it's a good idea to make sure that zeros, like 4 zeros, is put here instead of a 120 like localhost network, because it would not be accessible in other way. Course headers, it's all good. Let's a little bit further. Okay, here's another interesting section. Local address, it should be kept as this, because as far as it running in Docker, we point all our external ports to these 26K ports, so that is good. External address. In case if you have the external address like static IP address for your node, it's a good idea to put it here. And let's just basically do it. Let me just pull up my local IP. So we'll have the direct example of how that should be set. So TCP, here's the address, and our external port is 37.656. Okay, and here's the place for some seed nodes. If you have any, you can put them in. Actually, where you can find all the related info about the seed nodes, peers, and ask for some questions and maybe find the answers for some questions. I created a topic ILR5 on our forum. I'm going to publish a little bit more info like peers and seeds and so on there. So just follow that up, Cyber Congress IE forum and ILR5 branch there. And as we see, here's some persistent pairs, which was already pulled with the Docker. Okay, and there's a few most interesting things which is important when you're running a validator. So the PIX parameter. So PIX is a peer exchange reactor, basically the thing which allow node to exchange the addresses with the internal like network. And if you're running a validator, it's a good idea to keep this switch to false, because you like normally you wouldn't need to show to entire the world like address, like physical real address of your validator. It should be hidden, so we'll set this to false. And here's the private peers IDs field, which is also important. I'll probably go ahead and show up the screen again. I draw a little. Oh, come on, I go into. Sorry. Here is it. Yeah, so I draw a little diagram about the like good, cool Sentinel infrastructure for your node. Here you will see internet. Yeah, like this. So here's the internet, and here's your validator. So what's settled between of those, and what should be like technically in a best case settled between of those. So first of all, there is a couple of peer nodes or search nodes which is recommended to set to communicate with the world, with the chain, and to show up like their addresses to the chain, and like said like basically to sync your validator from them. So I'll just go ahead and cover. There's two lines here, two vertical lines, and behind of this first red line nobody except the peer nodes should know the addresses of your validator, and your validator should be just connected to this, like your trusted peer nodes, which you should like set up as well. And behind this black line, everybody could discover like whatever addresses and IPs and whatsoever accounts about your nodes. So keep the validator detached from the like exchanging his private info with the rest of the chain. Use the seed nodes, private peers nodes, sorry, to sync your chain. So technically, ideally, process should go as following. You connected 1, 2, or how many you would like to nodes to the chain, sync them, synchronize, get the fully synced chain on them, and then you're going to set up set up your validator on the third node or second, whichever is affordable, and you just point the validator peer to private peers IDs of these search or like peer nodes of your peer nodes. So it would not be shown to any other on the network except this node. So for example, if we have a couple persistent peers sitting here, and that's how the like a peer ID looks like. So if we will put this address, copy it and put it to private peers list, so it's not going, this node is not going to tell anyone on the network that it is connected to this peer, which is like cool in a way of security. So nobody would know your IP, nobody would know your port, nobody would be able to DDoS your connection and your node. All right, so what is important here? Well, everything is important. There's not the whole stuff I'm going to cover in this talk. Well, I guess basically it is. So just the keywords. If you're setting up your validator, make sure you will disable the PEX. Hold on, where is it? Oh, yeah. So make sure you will disable your PEX to false, so it would not run the peer exchange reactor inside of the node. And if you're setting up the validator and the seed node, like personal peer node, private peer node, make sure you'll have your validator node address inside of a private peer IDs on your sync nodes instead of just the persistent peers. Okay, so that is the keys of the Sentinel architecture, which is which will help you to run your validator like secure, at least like cover the basic security. So let's see what's going on with our node. Oh, and one other thing, if you're changing anything inside of a config, it is required to restart the Docker container after you changed something to apply all the changes. Otherwise, it would not pull them. All right, we'll see how many blocks. 8 is 9. It's almost, yeah, close to 12K. Yep.
Back to the diagram. So I have a Sentinel architecture here, but may I ask you about the validator replication? If something happens with my validator, I think the SSD is crashed or it's lost its internet connection. Is there any way to replicate it? I mean,
well,
the major thing what I worrying about it's the double signing. So
okay,
how to avoid
so
this?
if you want to run like 110% on reliability of your validator, you may do like this and create a second node for like a spare validator node which we will call validator spare. Oh, oh, I don't know. Where's the remote from the TV? The TV dead. Okay. Okay, if we are very cool and set up secondary validator spare nodes, we can, like, technically it is possible to monitor the state of your primary validator, and in case if the missed block count will rise up or if it will go online, it is just possible to keep the spare node start signing blocks instead of the main one. But yeah, it should be, you should be just very careful about the double signing to not make your like security work and two validators with the same keys start signing blocks, because you will be slashed with a double sign. And we have a fee with like a 2% of a stake. Yeah, 2% of its stake from your validator for double signing. So that's the worst thing you can imagine in terms of jailing. So it just better in this case than double sign. Just better just go to jail. It's 0.1% of the stake fine for it. So, but technically, yeah, it is just possible to do that. Keep the same keys on two nodes. Just one should be enabled. Both should be synced. One should be validating, and the second one should be like just sitting and waiting for the first one would go offline, like that. We not like provided any useful scripts for this setup to make the secondary like spare node start automatically, I believe. But I believe we'll do a little in the future. So this could be like slightly automated in this term. Okay, is there any more questions for the second? All right.
Guys, is anybody watching the YouTube? Because I have my computer. Can you have a look if there's any questions on there? Thank you. No? Okay. Any questions in the room?
Yeah. Oh, hold on. We have our node already synced. Let's see how much is in total. Yeah, it's 12,000, almost 13.
Almost.
Just 2 more minutes. Yeah. Yeah. Sync is. Sync.
Just for 1 day.
Yeah.
The later you connect to the network, the more you'll have to sync.
Maybe you can talk as well about jailing and unjailing. By the way, I don't think you mentioned jailing and unjailing.
Yeah. So currently for ELR 5 network, we have 240 blocks for a jail counter. So if you will miss at least 40% of each 240 blocks, in window, in 240 blocks window, you will be jailed. So technically, in a time, it's something about the half hour. And so you should be online at least 80% of time from a half hour, from each half hour, to keep validating and do not jail. It is possible to set up the monitoring on the node to monitor it with a Grafana or Prometheus to keep an eye on how many blocks is signed, how many is missed. That's also would be covered in our docs, how to set this up. All right, I guess we synced. Yep, we do. Okay. Let's go ahead then and start the validator. Probably we'll have to split the screen again. But I need 2 of those. So. Okay, returning back to our doc. Okay. Not this one. Where's the section? Okay, full node. We checked, we got it running. Okay, validator start. That's what we need. First of all, to start the validator, you obviously would need to gain an account with some tokens. Guys, today already discovered how it's possible to do that. So I'm just going to import an account real quick in the background to this node. Just a second, bear for me. So what I'm doing currently, I'm importing the account with some EUL tokens to the node. I just don't want to show my seed phrase to anyone, so I'm just doing that in a second window. All right, let's see what do we have. Okay. Layer 5, Super D, CLI, keys, list. What did I put wrong? Super D, CLI, keys, list. Oh. Yep. All right, here's my key. Mars, I called it Mars. And let's just go ahead and query how many tokens do I have there. So chain ID is ELR5. All right, cool. Looks like 50 millions. Okay, that should be enough to start the validator. Okay, we're skipping that. We added our key. All right, then we need to discover the Tendermint validator key, which looks like that. Cyberval conspop key. And then we need to go ahead and construct this transaction. I'm just going to, is it okay to see? Okay, this way. So what's important here, your commissions, max rate and max changing rate. Let's go ahead and put a commission, I don't know, 0.42%. Then we should specify the name from which, the name of the account, which is Mars for my case, from which we're starting our validator. Here's the moniker. Yeah? No, would not go like this. We'll put Mars. We'll use the unique moniker. And I just lost my pub key.
Scroll up.
Yeah, cleared the output. So, but we discovered this earlier, and I'll just go ahead and paste it. Okay, mean self-delegation amount is the amount of tokens you setting up for yourself. You could not delegate less than this amount, and if your stake will fall lower than this amount, your validator will be jailed also. And here's the important thing, amount of yields we are going to delegate on our validator from the scratch. So it's 49, 1, 2, 3, 1, 2, 3, 49 million. So left a little to conduct the transactions. UR5 container. All right, let's, oh my God. Yeah, let's see. All right, my password. All right, cool. Is it succeeded? Success true. All right, cool. Let's see if our validator is appeared here in validator section. And probably would take a second for it. And here is it, Mars. Okay, cool. We are now validating. We see our stake. It's 2.39% of whole stake. Yeah, it's all self. Our commission. Okay, so pretty good. We're validating the network. Okay, if there's any more, well, I guess that should be pretty much it.
I have one more thing. It might not be related directly to this, but it kind of related. There is on the website we have CLI command list. So maybe you can go over there a little, or is it not updated yet for EULA 5?
Yeah, we have the ultimate guide with pretty much most of the commands, or where is it?
CLI guide.
CLI guide.
I think it's there.
Yeah, somebody renamed it. Okay. Well, so here's discover pretty much all of the commands for the CyberD CLI. Let's maybe try to link something. Link.
Better way to use --call flag.
Oh yeah. Okay, linking content. That's what we need. So basic thing you can do from it. So a couple CIDs. Alex, could you send me some? Let's see, what do I have in the background here? Oh, come on, where's my CIDs?
You can link the cyber ward. Yeah, that's the hash of cyber ward. Keyword,
The guys are just exchanging CIDs for anyone who is watching the recording, where to link from and to.
So here's the hash of the keyword we would like to link from.
You can only use hashes when you're linking from the CLI,
From
right?
the
You couldn't
CLI,
use direct addresses, right?
Yeah. Better go to cyber page or a cyber virus extension to use in a more human way, humankind way, with the words, not the hashes only.
What are the advantages of using CLI to link rather than using cyber page or cyber virus or cyber virus, not cyber page?
Well, I guess it just trust. If you don't trust to the cyber page, you don't know maybe what's going on under the hood there, or you don't trust the virus. Here's the node. Here's your. I mean, it's located where you know, and you may trust all your keys are stored inside of a node. So, I guess the better idea is the trust, security. Yep.
Just say that you don't need to local node to just use CLI. You
Oh yeah, it is.
dedicated node.
Yeah, it is possible to just build up just a CLI, like install the CLI to your computer, connect it to remote node, and like do all the operations with it, like locally with the local CLI and remote node. All right, let's put the name. Mars and
Kirill, is there a guide how to connect to a remote node on a CLI?
I believe it's here, supposed to be here in Ultimate Guide also.
Just use Titan node.
You want me to connect it? All right, let's do the link first. Password. I guess it succeeded. Let's try to search. Huh.
I'm not sure that the content should be available now.
We'll see. We'll link cyber, right?
Yeah.
And here's our hash. It's didn't have the rank discovered, decalculated for it. Let's try to open. Yeah, kidding. Cool.
Yeah, someone should do that. First,
More kittens, more
first get
kittens.
solid,
Yeah. Okay, and the remote node. Let's see if it's. Oh, yep. Looks like it's not discovered here in this guide. We'll probably have to add it here. Connection to remote node. So I'll probably skip it for now. All right,
questions,
guys.
guys?
Is there any more questions?
Anything on YouTube, Alice? No?
Yeah.
No, no YouTube. Who is it? Who is it? Yeah, I think we have one more thing. Any more questions?
Yeah,
No? Okay.
All right. Yep. We'll skip it. All right. So yeah, I guess that's it. So we've been able to set up the validator. So we now are validating our network. So yep. Hope you guys enjoyed this talk. Thank you.
Thank you. Wait.